As a part of this class, let's take an example of dependency injection and understand it in some detail. Now there are a whole host of frameworks which help with dependency injection. Google's Juice is one such framework. There is another framework called the Spring MVC framework. All of these solve multiple problems, but at the core, they help with dependency injection. The example we are going to look at right now uses the Java FXML framework in order to solve our dependency injection issues. Why do we need dependency injection? Dependency injection allows a class which uses many different services to not know about the instantiation of each of these services. Instead, its member variables, which are these services, are injected into the class. This allows the instantiation of the class to be simple, and it's the injector which holds all the complicated information of what class to instantiate and inject into a particular class. Let's see an example of this in action. Now, JavaFX user interfaces can be built in two ways. One is programmatically and the other is declaratively. What does this mean? Programmatically building up a user interface is the traditional way. The model view controller, which is the design pattern on which JavaFX user interfaces are built, are entirely specified in Java. All the UI components are specified in Java code. Declaratively uses FXML. The model and the controller continue to remain in Java because that's where the logic is, and logic should be in code, but the view, which is essentially a design, is specified in FXML. FXML is an XML file format. It's built atop XML in that it uses tags and markup, but it provides a standard way to specify Java objects. The objective of FXML is a way to specify a Java object completely such that it can be instantiated in code. Java code uses Java objects. That is a truism. FXML is a way to describe Java objects in XML using markup and specific tags. Once we have these Java objects, they can be effortlessly loaded into Java code using a special class especially made for this purpose. And that class is the FXML loader. FXML is a big deal, and it has a whole host of advantages which we'll take a look at shortly. Let's see why. Now, if you've ever written any UI code, you'll know that UI development generally tends to be very messy. There are a whole bunch of moving components on the model, view, and the controller. Keeping all of these in sync is a hard problem. With the use of FXML, designing the UI becomes really quick and easy. FXML essentially decouples how the UI looks and feels from what the UI does. So basically, designing the UI becomes really easy and decoupled from the logic behind the UI. What is the additional implication of this? This means that UX designers and software engineers can each individually focus on what they do best. UX designers are great at designing UI and determining how it should look and how it should interact. Software engineers are great at writing the code behind the UI, making sure it works correctly and predictably. Each of them can focus on what they do best. Now, user interfaces, which are notoriously hard to reuse, they are not really modular, will now become modular and plug and playable. Essentially, you can pick up a piece of FXML and plug it in somewhere else. modularizing your UI. A really big deal and a big win for the reusability of UI code. Another issue with UI code is code bloat. Code bloat happens when there is a lot of boilerplate code written for even simple functions. UI code in Java generally has a lot of this boilerplate, and reducing this code bloat is what FXML helps with. And lastly, FXML allows JavaScript and other scripting languages to be used seamlessly inside JavaFX apps. This makes JavaFX even more powerful than using just plain Java. JavaScript, style sheets, so on and so forth make building UI really powerful and make it even more engaging and customizable. All of these abilities are now present within JavaFX using FXML. All this is great, but the most important thing for us right now is to figure out how this FXML setup really works. We can look at the details of each of these, and you can look it up on your own account. As a part of this class, we are not going to go into those details. You can look at our JavaFX classes, which will have all of this information. However, we'll now look at how FXML works and how it helps with dependency injection. The very first step in setting up UI using FXML is to have a UX designer put together a sleek UI without touching any Java code at all. This is possible because of a JavaFX tool called Scene Builder, which allows a WYSIWYG way of specifying the UI. The UX designer simply has to drag and drop the UI controllers onto the screen to lay out the UI exactly as he or she wants it to be. There is no coding involved at all. Step 2. Scene Builder allows the UX designer to save the UI into an FXML file. You simply hit save and it generates a whole bunch of XML with the FXML specification of the entire UI which has been built without touching any code. So we have the UI, we save it as FXML and move on to step 3. Step 3 involves the Java programmer. He picks up that FXML file and loads it into his Java code using FXML loader. If you remember what we'd mentioned earlier in this class, FXML loader actually instantiates Java objects from this FXML file. Each tag in the XML represents a Java object or its attribute. We move on to step 4. If you realize the FXML and the Java now make assumptions about each other. Because if the programmer is expecting certain classes to exist, which he wants to wire up, they have to exist, and the UX designer has to specify them in his layout. The UX designer and the programmer must be in complete and perfect sync for this to work. The controls have to exist as the programmer expects it. They have to be named correctly. They have to behave in the correct way. This cycle is what allows us to build UIs in FXML and use it within our code. This lays the foundation for understanding FXML and how it's used within JavaFX. The next step is to understand how FXML performs dependency injection and makes writing of code in JavaFX far easier than it would have been otherwise. Let's take a look at that in the next class.